Hello, and welcome to the next video in the series for mold design. In this video, we are going to discuss selecting, adding ejector components, placing and sizing ejector pins, trimming and pocketing the ejector pins, and creating and exporting pin charts. We left off adding two lifters in the last video. I've added the others to the rest of this mold. Since we now have the relevant mechanisms in place, we can look at where we would like to place some ejection. Here I'm only showing the core side and the ejector components. I need to show all the components that may be affected by placing the ejector pins, also to make sure there are no collisions. Once I select the Add Ejection button, I will now get a dialog box. This dialog box will allow me to select the components I would like to add from the catalog. I will now choose a pin diameter, 1/4 inch, and I'll worry about the length later. These pins will be added in accordance to some add rules we've already placed in the catalog. Once I selected the pin, it will now ask me how I'd like to place it. I'm placing it on the face. In this case here, I'm looking for the bottom of the retainer plate. It has some sketcher tools available to me. I'm able to select the pin by diameter using the sketcher tool circle function. I can now type in the diameter of the circle, and that will allow me to select different size pins. This is done with a feature in the pin catalog that looks at the diameter of the pin as the part size. So it'll automatically go through the catalog and select the diameter for me. I know this part is symmetrical, so I'll use the line of symmetry in the sketcher tool to allow me to place two pins at the same time, one on each side. This will make the job a lot more efficient. Zooming in, I can now start placing my pins where I see fit. Here I will put a 3/16 pin, and I can see I now have one placed on symmetrically opposite side of the part. I'll continue putting pins in this fashion. I can now choose a different diameter pin by just simply changing the diameter of the circle I'm placing. Here I chose 1/4 inch. And I will now continue to place my pins in the tool as I see fit. Since we're using the sketcher tools, I could use the sketcher function. I could use some of the sketcher tools to help me place some pins in line with each other. Now that I have placed some pins in my mold, I can now continue placing or accepting this. I could go back later and edit this and add some more if I'd like. System now is now calculating all the lengths it needs necessary to determine the length of the pin that I'm going to need to order. This was done through our add rules. You can see here I have a couple different length pins based on the geometry of the part. You see here they are all placed on the bottom of the retainer plate. Now I'm going to go and trim these ejectors. By selecting all the ejector pins, now a few options. I can trim them by movable side or the top of the core block. In this case, I'm going to use the actual work part. So it's going to look for the core side of the work part and trim to those. I could have a shape trim, or I could leave it flat, and I could even offset those. Once I accept that, the system's now going to trim all my ejectors to the bottom of my work part, or the core side. So now take a look and see how they were all been trimmed. Now I'm going to use the ejector pocket feature, and this will allow me to pocket the ejector pins as I see fit. Once I select all the trimmed ejectors, so all the pins that have the attribute of ejector pin will select automatically. And we'll look at our options here. I can use the active part as reference. In this case here it would be the active subassembly, or I can use a work part as reference, which I'm going to choose. And then I have some options of how I'd like to pocket these out. In this picture, we can see that we can have a length of fit or reamed hole. We have clearance, which we can designate, and we can either have a fit length all the way through, a clearance length all the way through, or a combination of both. In this case here, I'm going to choose to have a constant fit length. So a reamed hole from the part is going to be consistent with each pin depending on where the part face is of 2 inches. I'm going to accept this and let the system determine my pocket fit length. We can see here that we have a consistent length of 2 inches from the part face, regardless of where the pin sits on the part. You can even see a pocket, the retainer plate. This would be done the same as if I had a keyed pin. Next, now we're going to use the table of ejectors function. What this will allow me to do is select the pins I decide to put in a chart or a pin chart based on some settings. So it automatically picks the trimmed and pocketed ejectors. In this case here, I'm going to select the return pins because these are designated as return pins, not as ejector pins. But they have been cut, and it will also allow me to put them in the chart. Looking at the settings, we can see I can choose the font. I can automatically underline 6 and 9. I can create numbers on the pin or the plate, give it a size, color. I can even change the angle give it a prefix or a suffix, and I could choose how I want to number the plate, starting from witchboard corner, either horizontally or vertically, and I can decide what number to start from. By accepting this, the system will now create its own pin chart in an Excel file. I'll choose just to put it on my desktop for now, and it'll automatically open. Here's a generated pin chart, and we can see that our catalog names of our pins are there, our pin diameters, our lengths, whether they're keyed or not, and also their X and Y and Z location. Zooming into the underside, we can see that we have text or engraving on our plate and our pins. So this can be set out to the machine, the shop, and if they so choose to engrave the plate, they can do so. Thanks for watching this video on adding ejector components. I hope you found this informative, and look for our next video in the small design series, adding cooling components.